Hello there, my name is Gregory Carlson, and the next problem says a rectangular piece of metal is 5 inches longer than it is wide. Squares with sides of 1 inch long are cut from the 4 corners, and the flaps are then folded upwards to form an open box. So if the volume of the box is 500 cubic inches, what were the original dimensions of the piece of metal? A problem like this is very difficult to do unless you draw a picture. So let's draw a picture really quickly. We have our original piece of sheet metal, and what they did was they cut 1 inch corners out of it. And so all of these corners that we have here are each 1 by 1, 1 by 1, 1 by 1, and 1 by 1. Then what they've done is they've taken the remaining sides and folded them up to form a box. And because I'm a visual person, I actually made a little diagram to show you. So you can see here I have my sheet of metal. I've cut out the 4 corners, as you can see. And if you do that, you can see that the box folds up and forms a nice little box. And so the volume of this box is 500 inches. And you'll also notice that what is the height of this box? If you unfold it, you remember that these are each an inch by an inch. So if they come up like this, the height is actually just going to be 1 because each of these length and width of the corners was 1. So hopefully you can see that. So the formula for volume of a box is length times width times height. I'm going to show you 2 ways to do this problem because it's a little tricky. So first off, what is this length right here? Well, if the entire thing is L, the length of the sheet of metal, then do you agree with me that this would be L minus 2? Because this from here to here is L, and so we need to take off this corner and take off this corner to get L minus 2 right here. That way, the reason I like doing it this way is because I'm solving for my final answer, which is the length of the original sheet of metal. So this is 1, 1, and L minus 2. Add those all up together and you get L. In addition, this piece right here would be W minus 2. Would be, the width minus 2. So this would be W minus 2. Now, they tell us that the length is 5 inches bigger than the width. So this would be L minus 2 minus 5. Because we need to take off the 2 inches for the 2 right here. And we also need to subtract 5. Because that means that because this is 5 shorter than this, the width is 5 shorter, we would need to subtract 5 if we're putting it in terms of L. So then what would the folded up box look like? It would be L minus 2, L minus 7. And hopefully that made sense. Again, this is L minus 2 minus 5 because I didn't want to put W here because I only want one variable. I want to put everything in terms of L. So volume is equal to length times width times height, which in this case is going to equal my length times my width times my height, which remember from my earlier explanation of folding the box, the height would be 1 because that's how these lengths right here, 1 and 1. So we know that this number is equal to 500, the volume. And if we FOIL these two, we'd get L squared minus 2L minus 5L plus 10. And now it's simply a matter of solving this equation. 500 equals L squared minus 2L minus 5L plus 10. So let's combine like terms. Combine negative 2L and negative 5L to give me L squared minus 7L plus 10. And from here we can just go the rest of the way. Let's take the 500 over, giving us 0 is equal to L squared minus 7L minus 490. So from here you could either factor or use the quadratic formula. I'm going to save us a little bit of time because I've already done the answer to this. So when you calculate the answers to this, you should get the following 2 answers. L is equal to 27. And L is equal to negative 22. So I just did the quadratic formula right there, which I've omitted. You should be able to do that on your own. And because this is an application problem, it doesn't make sense for the length, this length right here, to have a negative value. So the answer, we ignore that value, and the answer we get is just 27. And remember, because we put L in terms of the original length, we're done. 27 is the answer. Sorry, I have a bit of a glare I'm trying to fix. There we go. 27 is the answer, and because the width is 5 smaller, just take off 5 and you get your width. So there you go. 27 and 22 are the answers. Just to recap, I started by drawing my picture, and I said this entire side is L, which means the folded length is L minus 2 because I cut off the corners. The width would be the width minus 2, would be that length for the same reason, but by putting it in terms of the length, they said in the original problem that the width is 5 shorter, so I took off another 5. So I have L minus 7, L minus 2, and this has a width of 1. If I try to draw the 3 dimensions of the box, that is a height of 1. So it's length times width times height. Solve. From here you should be on autopilot. Move everything over, use quadratic formula to get the answers. You get the length equals 27, throw away the negative, therefore 5 less than that is the width. So that's how I would solve that problem, but there is another way to do it, so let me quickly just show you another way if that was too confusing. This way is a little different. What we're going to do is we're going to start with the folded box. So instead of cutting off the corners, I'm going to start with the box already folded. And so here's the length. And again, we know, in fact, this time let's actually even put it in terms of width. So here's the width of the box right here. And we know that the length is 5 bigger. So instead of writing L, let's write W plus 5. Because here's the width, and L is 5 bigger than the width, and so this is W plus 5. Now we're ready to go straight into our formula. Again, it was V equals L times width times H. And we know that the volume was 500. The length is W plus 5. The width is W, and the height was 1 for the same reason of folding the box with the corners. So due distributive property, we can ignore the 1. We'll get W squared plus 5W. And this maybe is a little easier, minus 500, minus 500. Maybe that's a little easier than the other way of doing it. So we have W squared plus 5W minus 500. From here you could either try to factor it, or you could try to use the quadratic formula. So I went ahead and did the quadratic formula, which I'm going to skip here, but you should know how to do that. And I got answers of W equals 20 and W equals negative 25. So that's what you get when you use the quadratic formula. Again, we'll ignore the negative answer, and so I get an answer of W equals 20. And so that means that the length right here is going to be 5 more than that, if 25. Now you'll notice that that's different answers than what we got last time. And that's because when we solved it this time, what we did was we found the dimensions of the folded box. And they wanted the dimensions of the original box. So basically all you need to do is just add the corners on and you'll get your answer. Because remember, we got answers of 22 and 27. Do you see that? 22 and 27. And so if you add the corners back onto this, you get the final answer of the width of the original box is 22 and the length of the original box is 27. So that way, there's 2 different ways to get to the final answer of 27 and 22. This way has easier numbers and maybe less thinking you have to do. But just remember this last step of, if you do it this way, you found the dimensions of the original box. And so we need to add 2 and add 2 for the 2 corners to get the width and length of the final piece of sheet metal. So I know that's kind of a tricky problem. Hopefully those 2 ways make sense to you. One of the neat things about math is once you start to get the hang of it, you do see how there's many ways to get to the final answer. This is a totally different method than the other one, and you should just pick whichever one you like better. My preference is for this one because your L and W represent the original thing that the question is asking, but pick whichever method is best for you. In the next part, I think we'll wrap up 1.5.